When historians speak about the 19th century, they often highlight industrialization, nationalism, mechanical invention, global imperialism, and scientific advancement. It was a century of significant change: the spread of railways, the invention of the telegraph, rapid urban development, political revolutions, and the birth of the modern world. Yet, beneath these recognizable themes lies another story: a global narrative of environmental shock, widespread famine, economic collapse, pandemic waves, and atmospheric anomalies that affected nearly every region of the planet. This side of the 19th century is far less discussed in mainstream accounts. Traditional textbooks tend to emphasize political events: the rise of the United States, the unification movements in Europe, the collapse of older empires, and the expansion of European colonial rule. What they mention less frequently, sometimes only in passing footnotes, are the catastrophic climate disturbances, volcanic eruptions, long-duration famines, pandemics, market failures, and social displacements that dramatically reshaped population patterns, weakened governments, and altered ecosystems. This documentary explores that hidden history in detail. It examines how the 19th century faced a series of interconnected crises, some of natural origin and others rooted in human decisions and imperial structures. The period was marked by unusual climate irregularities, including volcanic winters that reduced global temperatures, the emergence and worldwide spread of cholera, multiple mega-famines that claimed tens of millions of lives, prolonged financial depressions, and mass migrations triggered by environmental stress and economic instability. The global catastrophes of the 19th century were not isolated incidents. They formed a chain reaction that connected continents, economies, and societies. Failures in monsoon cycles in Asia influenced grain markets in Europe. Volcanic eruptions in Indonesia caused agricultural collapse in North America. Imperial policies worsened famine outcomes in India and Africa, and pandemics spread along the same trade routes that carried industrial goods and colonial commodities. This account reconstructs the century from a global perspective, drawing on modern climate science, historical epidemiology, demographic analysis, and economic records. Its purpose is to demonstrate that the 19th century was not simply an age of progress. It was also an age of profound vulnerability, shaped by environmental forces and human systems struggling to adapt. The 19th century did not begin with the stability and optimism that people today sometimes imagine. Long before the famous eruption of Mount Tambora in 1815, the planet was already experiencing unusual atmospheric behavior. Ice core samples extracted from Greenland and Antarctica indicate that a significant volcanic event occurred around 1808 or 1809. Surprisingly, no clear written record of any major eruption from that year has ever been found, leading modern experts to call it an orphan event. 1.1. The 1808 to 1809 atmospheric anomaly. Instrumental records from the early 19th century are sparse, yet surviving journals, ship logs, and agricultural reports show that global temperatures noticeably dropped during these years. Regions across Europe experienced cooler summers and harsher winters. In parts of North America, farmers reported unseasonable frost and poor harvests. Similar observations were made in China, Japan, and the Ottoman Empire. The cause was a significant rise in atmospheric aerosols, small particles that reflect sunlight and lower temperature. Such particles usually come from volcanoes. When sulfur-rich ash enters the stratosphere, it can circulate for months or years, weakening solar radiation and altering weather patterns. The absence of a historical record is unusual but not impossible. The eruption may have occurred in a remote, sparsely populated region where no literate observers were present. Some researchers hypothesize that the event took place in the Amazon basin or the South Pacific. Others point to volcanic deposits in Central Africa. Regardless of the location, the atmospheric impact is undeniable. This unrecorded eruption marked the beginning of a decade defined by climate instability. Although the world did not fully recognize its consequences at the time, it laid the foundation for the global catastrophe that would follow just a few years later. 1.2. Global agriculture before the eruption. Agriculture in the early 19th century was highly vulnerable to climatic variation. Most regions relied on rainfall, natural rivers, and traditional crop varieties. Irrigation systems existed in parts of India, China, and the Middle East, but they were limited. Technologies for crop storage, disease control, and long-distance food transport were primitive compared to modern standards. This meant that even small temperature drops or rainfall changes could devastate harvests. Agricultural yields in Europe, China, India, and North America fluctuated significantly from year to year. In some regions, 2 poor harvests in a row created a crisis. In others, one failed monsoon cycle could lead to famine. The 1808-1809 atmospheric event weakened global agriculture just enough to reduce resilience. When Tambora erupted in 1815, the planet was already unprepared. 1.3. Global trade and food security at the dawn of the 19th century. The world economy of the early 1800s was interconnected but fragile. Trade routes existed, but transportation was slow and expensive. The idea of shipping food internationally to prevent famine was neither technologically feasible nor economically rational from the perspective of empires whose priorities were profit and political control. For example, Britain imported grain, but only when market prices incentivized it. India exported rice even during periods of local scarcity. China relied mainly on internal trade networks, which were vulnerable to regional disruptions. Africa's food systems were undermined by the Atlantic slave trade and emerging colonial pressures. The result was a planet in which millions of people were always one poor harvest away from hunger. So climate shocks had disproportionate effects. 1.4. Early industrialization, more demand, but same vulnerability. While the first industrial revolution had begun in Britain, its impact on food security was limited. Industrialization increased populations in cities, creating higher demand for stable food supplies. Yet food production methods remained traditional across most of the world. Mechanized farming was rare. Fertilizers were not widely available. Crop rotation systems were inconsistent, and transportation infrastructure was limited. So the world was heading into one of the worst climate disruptions of the millennium without any modern scientific tools, technologies, or logistics systems. 1.5. A century predisposed to catastrophe. The early 19th century was a moment when climate systems were fragile, agricultural systems were vulnerable, trade systems were imbalanced, populations were growing, epidemics were common, empires prioritized capital over welfare, scientific understanding of disease and climate was minimal. It was, in many ways, the worst possible time for a massive environmental disaster. And yet, the world was about to experience not just one, but a series of devastating events that would shape global history. The stage was set, the world was unprepared, and Tambora was about to erupt. While Europe struggled through what would later be called the year without a summer, scientists observing long-term climate patterns realized something unusual was occurring. Tree ring studies from North America, Siberia, and the Japanese Alps later revealed that the early 19th century experienced one of the most significant global temperature drops in the last 1,000 years. These rings show slow growth, indicating shorter summers, colder winters, and limited sunlight. This climate downturn, starting around 1809 and peaking in 1816, was not confined to one region. Across the Indian subcontinent, rainfall patterns became erratic. In the Yangtze River basin of China, winter frost lasted weeks longer than usual. Ships crossing the Atlantic recorded unusually strong storms and unpredictable winds, suggesting broader atmospheric disruption. The average global temperature is estimated to have dropped by 1 to 1.5 degrees centigrade, a seemingly minor number that nonetheless made catastrophic changes to agriculture and food supply. Crops that required warmth, such as rice, maize, and wheat, failed repeatedly. Even hardy grains struggled. Livestock died from cold and lack of fodder. For decades, historians believed this temperature anomaly was purely the result of Tambora's eruption. However, modern climate reconstruction suggests multiple volcanic events might have contributed. Ice cores from Antarctica and Greenland contain sulfate spikes, indicating eruptions in 1809, 1812, 1814, and 1816. These do not all correspond to known volcanoes, meaning at least 2 eruptions occurred in remote regions where no written observations survived. What makes the early 19th century climate shift remarkable is the global synchronicity. Crop failures happened on nearly every continent in a short time frame. In this way, the climate downturn behaved unlike the localized cooling seen after other eruptions. It was widespread, severe, and long-lasting, pointing to a chain of volcanic activity that effectively dimmed sunlight across the Earth. Every pre-industrial society depended heavily on predictable weather. When the climate shifted so dramatically, famine spread with unprecedented speed. China, a hunger crisis in the Qing Empire. China was one of the hardest-hit regions. The Qing Empire recorded widespread agricultural collapse between 1810 and 1820. The famed rice regions of the Yangtze Delta experienced continuous flooding, followed by dry seasons that devastated production. Peasants abandoned farms and fled to cities in search of food, overwhelming local granaries. In some provinces, notably Shanxi and Hunan, famine led to mass migrations and violent uprisings. Local records describe people eating roots, bark, or in extreme cases, the bodies of the dead. Government relief efforts proved insufficient, and by 1818, millions were believed to have starved across the empire. India, the monsoon failure and British policies. British-controlled India also suffered severe food shortages. Volcanic aerosols altered monsoon patterns, delaying rainfall and causing drought in Bengal, the Deccan, and the Madras Presidency. Large segments of the population depended on seasonal rains for rice and millet cultivation. When those rains failed, food scarcity followed. The British administration exacerbated the crisis by maintaining grain exports to Britain and imposing taxes even during famine conditions. Transportation networks were inadequate, and millions lacked access to emergency relief. The famine of 1816-1817 remains understudied but was one of the deadliest events of the century. Europe, hunger on an industrial scale. Even Europe, with its growing industrial economy, struggled. In France, grain prices tripled within a year. In Switzerland, where cold and snow destroyed crops entirely, food riots erupted. Reports from Germany describe entire villages living off boiled grass and animal bones. In Ireland, a precursor to the later Great Famine occurred. The 1816 potato blight reduced yields drastically, forcing thousands into debt or homelessness. By 1817, the situation had become so severe that British newspapers began describing Ireland as being in a state of collapse. North America, the failed harvests of 1816. The United States and Canada were not spared. Vermont experienced massive crop failures, prompting waves of migration westward to Ohio and the Great Lakes region. It was this forced movement that later shaped early American settlement patterns. New England, normally temperate in summer, experienced frost nearly every month. Many historians argue that the climate crisis accelerated the decline of agriculture in the northeastern states and pushed the population toward industrial employment. Global mortality. It is impossible to calculate an exact death toll, but modern estimates suggest that 10 to 15 million people may have died worldwide from famine, disease, or cold during the aftermath of the 1810 to 1820 climate anomaly. This makes it one of the deadliest natural catastrophes in modern history, yet it is rarely mentioned in textbooks. One of the least understood consequences of the early 19th century climate crisis was the emergence of a new, devastating disease, cholera. Before 1817, cholera existed only in small, localized outbreaks in Bengal. It was dangerous, but geographically limited. However, the monsoon failures, famine, and massive population displacement created ideal conditions for the bacteria to evolve and spread. The first cholera pandemic begins. In 1817, a highly virulent strain of Vibrio cholerae emerged near the Ganges Delta. Within months, it spread along trade routes to Calcutta, Bombay, and beyond. British soldiers carried it through their transport networks. By 1818, cholera had reached Southeast Asia, the Middle East, and even parts of Africa. Between 1817 and 1824, tens of millions were infected, and hundreds of thousands died. This outbreak was the first officially recognized global pandemic in recorded history. Why the climate crisis triggered a pandemic? The link between the climate anomaly and cholera is now supported by several studies. Heavy volcanic aerosols weakened monsoons, altering river salinity and temperatures. These altered water conditions favored the proliferation of the cholera bacterium. Famine and malnutrition weakened populations, making them more vulnerable. Increased human migration spread the disease rapidly. The pandemic reshaped global health policy, and yet it is rarely discussed in connection with the climate event that helped trigger it. Chapter 7: Social Unrest and Political Collapse. When food becomes scarce, governments often fall, and the early 19th century provides multiple examples. Europe on the brink. By 1817, hunger riots became a regular occurrence in England, France, and the German states. In the United Kingdom, bread riots targeted merchants accused of hoarding grain. Military forces were deployed to suppress uprisings. China's crisis deepens. The Qing dynasty faced simultaneous pressures: famine, rebels, and economic decline. While not the sole cause, the climate crisis played a major role in weakening the empire long before the Opium Wars began. Several secret societies gained followers during this time, capitalizing on the desperation of the poor. India, anti-colonial tensions rise. In India, famine and disease eroded trust in British rule. Several local rebellions emerged, although they were quickly suppressed. Nevertheless, these events sowed early seeds of anti-colonial sentiment. Latin America, independence movements accelerate. The climate crisis coincided with independence movements across Latin America. Food shortages and economic instability weakened colonial governments, enabling leaders like Simón Bolívar and José de San Martín to gain support more easily. While political aspirations were the primary drivers, environmental strain played a contributing role. Chapter 8: Agriculture Reinvented. Humanity had to adapt rapidly to survive. The rise of crop diversification. Farmers across Europe and North America abandoned traditional crops and experimented with new ones. The failure of wheat led to increased cultivation of barley, oats, and hardy root vegetables. In Asia, rice paddies were redesigned to conserve more water. The shift toward mechanization. Food insecurity accelerated industrial innovation. Threshing machines, improved plows, and new irrigation methods gained popularity. The agricultural revolution of the 19th century, often attributed solely to technological progress, was in part a response to the crisis created by volcanic cooling. Chapter 9: The Scientific Revolution that Followed. The global catastrophe spurred unprecedented scientific curiosity. Birth of modern climate science. scientists began recording temperature, wind patterns, and atmospheric data more systematically. This period saw the rise of meteorological societies, long-term climate observation programs, and early theories of volcanic forcing. Many scholars now argue that the modern field of climate science originated partly as a response to the early 19th century anomaly. Medical science advances. The cholera pandemics inspired breakthroughs in epidemiology, sanitation, and public health policy. These developments laid the foundation for modern disease control systems. Part 2, End. Ready for Part 3. If you want, I will continue immediately with Part 3, chapters 10 through 15, until we reach the full 11,000 words. Just reply, Continue Part 3.